about other things on Monday. Before I get into the notes, what am I thinking? Today is Monday, and so I like to kind of go over the week schedule to make sure that everybody's on the same page. Okay, does everybody know we do not have school on Friday, right? I'm not quite sure why you don't have school this Friday, but you don't, so we'll take it. And you also do not have school of the following Monday. So you don't have school this Friday, you don't have school next Monday, and then because of parent-teacher conferences, you don't have school the next Friday. So you're like really having a lot of no school days. I don't know. Is everybody aware of that? Should I bring it up on the big calendar? So we are here in the 8th here. And so you do not have school on the 12th. You do not have school on the 15th. Parent-teacher conferences are on the 17th, the 18th. And you do not have school on the 19th. So there's a nice little 3-day week there. Okay. So that's kind of what we're looking at. So if you want to see what we're doing this week, today we're going to talk about balancing equations. Tomorrow, yeah.
Just because we got it up there.
Let's talk about it. Yeah.
The 25th and 26th are also those remote days.
Oh, yes.
Yeah.
I should add that in there. Thank you. The 25th and the 26th will be when the teachers are getting their second round of their vaccine, so they will also be remote. Good. Oh, 24th and 25th. No, 25th and 26th. Over here. Okay, so your unit test here will be remote. Okay. And you guys will be here for the review, though, and then you'll be remote after that. Okay. Awesome. Yes, thank you, Mr. Duchamp. So we are balancing equations tomorrow. We're going to talk about types of reactions and continue to balance them. Wednesday, we will practice it. And then instead of the lab on Thursday and the quiz on Friday, the quiz will be on Thursday since we do not have class on Friday. And then we do have a fun little demonstration that you will have there. The other thing I have updated on the one I was just on, though, is that on this Thursday, we do have an extended advisory. So our Thursday quiz day is a little shorter because you guys are going to be scheduling on Thursday. Okay, so 2 days of notes, 1 day of practice, and then a quiz. That's what we got this week. Perfect. All right. And then the other thing that I did just want to go through, because the other thing I did want to go through, just because we are scheduling, is that I had a little PowerPoint up last week, and students were having questions, wanted me to send it to them. So I made sure with my curriculum coordinator that this was all updated. I have this PowerPoint sitting right on my desktop, or right at the very beginning of our class. I think the second slide in is the most helpful. This is all the classes that we offer. But if you're like, hey, I want to know what ecology entails, if you slide through, there is a slide on every single, so like what is anatomy and physiology? Well, it tells you how many credits it is, it tells you what it is, and it tells you the topics, and then there is a slide with pictures on it. So you're like, what's ecology? It tells you how many credits it is, it's an advanced life science, and then there are the topics. So if you want to go through, once you get your course sign-up sheets tomorrow, what is zoology? It goes through every single science class we have there. What are the health pathways courses, things like that. Okay, so this is up there. Well, you're currently taking chemistry, so you don't need to know that. But we don't offer geology here. But if you're like, what is physics? Physics is motion, forces, work, momentum, waves, all the big things, or small things in chemistry. What's the difference between AP Physics 2, AP Physics C, all that kind of good stuff, some of the engineering stuff. So that is all up here if you want to go through it before you do scheduling on Thursday. Okay, so if you have a question, it should be answered there. If not, please let me know and I can answer it. Okay, perfect. All right, so that is kind of a rundown on the week and a rundown on scheduling that you'll be doing by Thursday. All right, so let's get into it. Balancing equations. So we have an equation here. This one happens to be the synthesis of water. We have some hydrogen and some oxygen gas, and they are going to come together and they are going to make water. I want to remind you something that we did at the beginning of the year. The beginning things are called the reactants. The things that you start with are called the reactants, and the things that you end with are called the products. So all we're going to be talking about today is around this arrow. And remember, the arrow means yield. But the biggest thing today is that the number of reactants you have today are going to have to equal the number of products you have. So the number one question that I get a lot, and you might see it on your quiz, just saying by Friday, is why balance equations? What am I talking about? Do you see how many hydrogens do I have here am I beginning with? I'm beginning with 2. I'm ending with 2. I'm starting with 2 oxygens, but how many oxygens am I ending with? I'm only ending with 1. So a lot of people are like, well, what does it matter? Who cares? Can't you just leave the reaction like that? And there's this really big law that we learned in the second unit that says matter can't be created or destroyed. It's called the law of conservation of mass. Very good. Okay. So we have to balance equations because of the law of conservation of mass. If you start with 2 oxygens, you surely better end up with 2 oxygens as well. Okay. The mass before the reaction must equal the mass after. So that means we must account for every single atom. Okay. So again, we are talking on the left and the right side of the arrow. The arrow is where we need to check out is our little teeter-totter. We got to make sure both sides are even. All right. So what you might see a mistake is somebody might be like, oh, okay, so you have 2 hydrogens, 2 hydrogens, 2 oxygens, 2, you know what you're going to do? Let's just put a 2 right here. That makes everything better. Now, there's a problem. You may never change the chemical formula. You may never change the chemical formula. And the reason being, water, you can drink. It's refreshing, delicious. H2O2 is called hydrogen peroxide. Does anybody know what hydrogen peroxide does? If you put it on a cut, it will clean your cut. If you put it in strong enough on your hair, it will bleach your hair. If you use it in the strong enough concentration, it's rocket fuel. That is a big difference between water. Okay, you put water on your hair, it doesn't bleach it. You put hydrogen peroxide on your hair, it will bleach it. So you cannot just add a subscript. If you want to balance an equation, you can only add a coefficient. Add a coefficient. Now, the only problem is that the coefficient affects the entire formula. And so we are going to take a look at this today because as soon as you put a number, it's a big number in front. For instance, if we have H2O, the coefficient is a big number you place in front. Now, the only problem is that this number distributes all the way through. If you wanted it to just affect the oxygen, I'm sorry, it also affects the hydrogen. That's what makes balancing equations challenging. Okay. Other just little teeny tiny rule, just to keep everything neat, is if you have no coefficient, you assume a 1. So don't start putting 1s everywhere just because nothing written there means 1. Okay. All right. So let's just jump in. I used to give you a whole bunch of different practice, but let's just get in here and see you guys start balancing some equations. We'll just start with the one we were talking about at the top. This is called the synthesis of water. My suggestions to help you with balancing are right up here. I suggest doing what's called an atom inventory. Underneath the yield sign, I write all the elements that we have. So I have hydrogen here, and I also have oxygen. So I suggest with me, go ahead and write down the hydrogen and the oxygen. Now, on the reactant side, I write how many I have. And on the product side, I write how many I have. So how many hydrogens am I starting with here? 2. Perfect. How many oxygens am I starting with here? 2. How many hydrogens am I ending with? 2. And how many oxygens am I ending with? 1. So now I can check easily and see if everything is balanced. 2 hydrogens, 2 hydrogens, 2 oxygen. What? Is that balanced? It is not. Now, I have these little lines out here. They eventually can go away, but these lines are the only place that you can write anything in order to balance this. what coefficient number times 1, what times 1 gets me 2? 2, right? So what I'm going to do is I'm going to write a 2 right here. As soon as I do that, though, I need to change everything that's affected. This 2 gets me how many hydrogens? 2 times 2 is, so I cross off this 2 and I put, there's 4 hydrogens now. That's okay. We can fix it. And then 2 times 1 oxygens gives me how many oxygens? Beautiful, 2. Very good. So did I end up balancing my oxygens? I did. Did I screw up my hydrogens? I did. But I bet you there's something we can do. When you come back over here, what times 2 can give me 4 hydrogens? Another 2. Very good. Okay. That's going to get me 4 hydrogens. I don't write anything in front of the O2. Let's take a moment really quickly, though, just for a common misconception. This 2 only talks about the hydrogen. It does not go past the plus sign, okay? So the 2 is only talking about the hydrogen, so I got 4. So I have 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. This is balanced, okay? They will get harder. We're starting easy. Then another thing that we like to do, and again, drawing is, some people love drawing, some people hate drawing, but we've talked to a lot of post-secondary professors and they say, hey, it's nice if they can balance it, but you know where the problem solving is if they can see what the reaction is doing. So what we're going to do is we're going to draw this out. The number in front tells you how many you have of this is what is bonded together. So if I could see 2 H2 molecules, it would look like this. Here's an H2 and here's an H2. There are 2 separate H2s. Let's draw that out real fast. Two sets of H2. Do you see that these are touching? So they're bonded. These are touching, but there's 1 set of them, 2 sets. And then that's going to react with 1 O2. Okay, that's an, remember, these are diatomic, so they stick together to be stable until they find somewhere else to live. And then how many water molecules do I end up making? What is this big number in front of my H2O? I end up making 2 separate water molecules. And so what you can kind of think of, that means that this hydrogen comes along and it breaks apart this oxygen, makes 1 water. And then this hydrogen takes this oxygen, you make 2 water molecules. So if in your head you can start to see kind of what's happening, that's actually a higher level of understanding than just 2, 1, 2 with your coefficients. Okay, perfect. But I don't know that we will be able to get you to draw on your quizzes. So, well, let's balance another one. Perfect. Flip to the next one. Give it a shot. Let's see what you can do. Let's see. You write an atom inventory underneath the arrow sign. We have sodium and oxygen reacting together to make sodium oxide. So underneath the arrow, let's write what elements we have. What's one of the elements I have in this reaction? Sodium. And the other element I have in this reaction is oxygen. Good. Remember, on the reactant side, we're going to say how many we have. On the product side, we're going to say how many we have as well. How many sodiums do I start off with in my reaction? 1. Very good. How many oxygens do I start off with? 2. How many sodiums do I end up with? 2. And how many oxygens? 1. And again, you cannot change the formula. Sodium oxide has to be Na2O. It's the way it has to be, so we have to balance around that. Now, it's okay to make mistakes in balancing. I'm actually going to make a mistake now, and that's okay. We'll show you how we go back and fix it. If you want to start at the top, you're eventually going to learn you always want to start with your oxygens. But let's start at the top today. I have 2 sodiums, and I have 1 sodium. So what might you put here in order to balance that? Put a 2 there, because, again, the coefficient distributes through. It multiplies through. So 2 times 1. that gets me 2 sodiums. So if I balance my sodiums, perfect. I have not balanced my oxygens though. What number do I put in front of this multiplied by 1 to get me 2? Good. Let's put a 2 there. Oh, man. Now that's going to mess some things up, but that's okay. How many sodiums does that give me now, though? 2 times 2 is 4. Okay. But then 2 times 1, how many oxygens do I have? You got 2. So are my oxygens okay? They're all right. Let's go back and undo our sodiums, though. So 2 oxygens, I'm good. 4 sodiums, what times 1, and this is nice and easy, what times 1 gets me 4 sodiums? Yes, perfect. Let's put a 4 there. Oops. Then you got to change your inventory. Let's check it out. 4 sodiums, 2 oxygens, life is good. Let's draw this out. You have 4 individual sodium atoms. 4 individual sodium atoms. Good. And then you're going to react with 1 O2. Now, how many sodium oxides are you making? You're making 2 individual sodium oxides. So you're making 1 sodium oxide, 2 sodium oxides. So what that's going to look like is 2 sodiums are going to come together and react with 1 oxygen. 2 sodiums are going to come together and react with 1 oxygen. So that's what's happening on a molecular level. All right, I might give you guys the challenge of trying the next one by yourself. Oh, it's a toughie. That's okay. All right, so those of you at home, any questions yet? All right, let's have you take a look at the next one. I want you at least to get the atom inventory done, and I want you to try to start. There is a common little trick on this one, but I want to walk around and see where we're going. I see us all dragging on Monday, so I got to change this up. Put this on quietly. At least go ahead and write down your atom inventory and tell me what you're starting with. Are you ready? So I got my beginning here as 1, 2, 2, 3. You might have said, all right, let me fix this iron. I'm going to put a 2 there. We're good. Did everybody get at least that far? Okay. Now we have an interesting problem. We have 2 and 3. What can 2 and 3 both go into? 6, right? What am I going to put in front of my O2? What times 2 is going to give me 6? 3. Perfect. Let's put a 3 there. And that gets me 6 oxygen. Now, what am I going to put in front of Fe2O3? So I'm looking here because that's what I'm trying to solve. What times 3 is going to give me 6 oxygens? A 2. Let's put that there. However, what did that do to my irons? 2 times 2 is 4. 2 times 3 is 6. So in the process of balancing my oxygens, I made one tiny problem. This is okay. I'm just going to go back over here. And what number am I going to put in front of that? I'm going to put, what times 1 gets me 4? I'm going to put a 4. Nice. Good, good, good. Okay. All right, let's try another. I know you guys can draw it. Let's try another one. I'm going to come around. I want everybody to write down your atom inventory. And I want you to give this one a try. Try the next one. Coming around. I might start hollering at home, people. Let's see. Hey, AJ. I know it's like,
Yeah.
Hey, do you have any questions right now? Are you working on this? Are you staying up? Is there anything I can answer right now?
No.
Okay, stay with me here. I'll check in again with you in a minute, okay?
Okay.
Awesome. Amber, talk to me. Good to see ya.
Hi.
Anything I can help answer right now?
Nope.
All right, I want you to start on this one. I want you to write your atom inventory and let's try to balance it, okay?
Okay.
All right. Claire, anything I can answer right now?
No, I'm good. I understand it.
Okay, perfect. Stay. You do this one. I'm going to give the answer in a second. John, what's up? Yeah. Are you on this one? Do you have any questions? Can you get this one started for me?
Not really. I'm trying to figure this out.
All right. Can we do this one together, John?
I guess.
Do you have the paper?
I do.
Okay. So let's talk about it. What two elements do you see we're working with in this reaction?
Nitrogen and hydrogen.
You got it. Can we put that here?
Right.
Do you agree that we're starting with two nitrogens and we're also starting with two hydrogens? Do we agree with that?
Right.
Okay. And we're ending with one nitrogen and three hydrogens. Do we agree with that?
Yeah.
All right. So they're not balanced, right?
No.
Should we start at the top?
Yeah.
Perfect. I have two nitrogens over here, but I only have one over here. Remember, it's a multiplication thing. So what number times one is going to get me 2?
2.
You got it. So can I put a 2 here?
Yeah. And then you put
Perfect.
1 over on the other side.
Or you can just leave it blank. We don't need to do anything. But first, before we go back over to the other side, can you tell me how many nitrogens that got me? That got me 2. But then how many hydrogens did that get me, John?
6.
Ah, that's a problem. So then you said leave a 1 over here, right? You leave it open. And then what do I want to put here in front of the H2 in order to make it 6?
3.
You got it. There you go. Okay, very good. So you just got to go back and forth, and then I guess I would change this to a 6, and everything would be balanced. Okay. Awesome. Let's try our worksheet. So thank you, John, for walking that one through with me. Everybody else in here and everybody at home, let's turn to the next page. Next page. Awesome. I'm going to make these get even harder. I know that you probably don't feel that. But so number 1 and number 2 are fairly easy. So I'm going to continue to do. I'm going to walk around, make sure you guys are doing good. I will do number 3 with you as it has just a little bit of a trick on it. But number 1 and number 2 are on the same par we have just been doing. So those of you at home, I'm going to check in with you. So you guys keep working along with us. I want to make sure everybody in here is okay. I want you to do number 1, number 2. If you are going along, because you know how to do this and you're doing great, the answer key is online if you want to check, okay? So I know some of you got this. Do some of them and check them online. I'm going to walk around in here. Those of you at home, I'm going to keep calling on you. Let's work on number 1. See if you can't do it. Let's see. Home. Let's do this next one. Run. Sorry, I forgot. I completely forgot. All right, here we go. So at home, those of you at home, hopefully we're having not a hard time with this. It's hard to check in with everybody. So I got sulfur and oxygen. Sometimes whenever you see 2 and 3, you can say, hey, you know what these both go into? They both go into 6. So the first thing I'm going to do is I'm going to put let me write it down. 3 over here to get me 6 oxygen here. I'm going to put a 2 here, but hold on. That gives me 2 sulfurs and 6 oxygens. So my oxygens are balanced, but oh no, we need a 2 here in order to balance the sulfurs. Okay. So the next one is almost exactly like that. Let's take a look. Aluminum oxide. Let's see who can get that. I'm coming around. I'm going to bother some people at home first. Where was I? Where did I pick up at home? Kayla, talk to me. How we doing?
Not good.
Not good. Okay, you want to do this next one with me?
Yeah.
All right, let's do it, Kayla. What elements do we have?
Oxygen.
We have oxygen, and what else do we have? Apparently, I didn't write any of this. I want to write that down here. What else do we have in here?
Aluminum.
Got it. Okay. All right. Now, how many aluminums am I starting with over here on my reactant side, Kayla?
Three.
Oh, so right here we're starting with 1 aluminum.
Okay.
Where I'm looking over here on the reactant side.
Yeah.
And then how many oxygens am I starting with?
1.
You see this number down here that's going to tell me I'm starting with?
2.
You got it. Very good. Very good. Very good. All right. How many aluminums am I ending up with? This number here.
2.
Yep. And how many oxygens am I ending up with?
3.
You got it. Okay. Now, it's easy to make a mistake. Let's go ahead and make a mistake. That's fine. Let's do our aluminums first. I have 2 aluminums on this side, and I only have 1 over here. What multiplied by 1 gets me 2?
2.
You got it. So I'm going to put a 2 here. Now my aluminums are balanced, correct?
Yeah.
My oxygens are not. What does 2 and 3 both go into? Two times 3 is going to go into 6, right?
Yeah.
Awesome. So what do I want to put in front of this O2 to get me 6? What times 2 gets me 6?
3.
Yes, very good. What in front of this O do I need in order to get 6? What times 3 gets me 6?
2.
Yes, very good. But as soon as I do that, I also have this 2 times 2 aluminums gives me how many aluminums? 2 times 2 is,
4.
You got it. So this can't be a 2 over here. This has to be a what?
4.
Yes, very good. Very good. And you're balanced. Good stuff. Good stuff. All right, let's try a harder one. We're going to bring everybody back together here. Number 3. The only reason why I think this might be challenging is because when you're pulling it out, we have magnesium, chlorine, sodium, and then it is not correct to keep the oxygen and the hydrogen together. Wrong. You have to pull it out completely. Okay? The oxygen and the hydrogen are on their own. So I want everybody to try number 3 now. I'm coming around. We still have plenty of time. I want everybody to try number 3, and then we will do the hardest one, and then we'll shut it down. Everybody try to balance this one. Let's do it. You can do this one. This one isn't bad. I know I'm like running out of time, but your answers should be out of order. Things are 2 here and 2 here. If you got that right, awesome. Let's try one of the hardest ones for the day, and I'm going to make you do your lecture questions, and we'll pick this up again tomorrow because I know this can get frustrating. Everybody at home, stay with me. I know I didn't yell at everybody, but I will yell at you. Let's try number 4. We have potassium, we have hydrogen, and we have oxygen. Stay with me here. Stay with me. How many potassiums am I starting with? 1. How many hydrogens am I starting with? 2. How many oxygens am I starting with? 1. How many hydrogens am I ending with? Be very careful. We have 3. How do we have 3 here? We have 2 here and 1 here. So that's 3 hydrogens, 1 potassium, and 1 oxygen. So remember how we were like, oh, put everything into 6. Sometimes you can't do that, okay? What I have to do is I have to make this even. So I'm going to give you a hint. Boom. I want you to start with a 2 right there, and then I want you to try to finish it from there. And we can talk more about why. I keep thinking we end at 55 and we end at 51. So I want you to finish this. We have 3 minutes. I want to see if you can finish this in 3 minutes. I'll give the answer up when the bell rings. But we are going to talk about types of reactions and continue to practice this tomorrow. The key to this is in the Monday folder. And I also do have the lecture questions I'd like for you to kind of get done at some time today. It's very, very simple. Okay. Coming around here in a second. Let me, who else did I bother? I didn't finish